Okay, well now we're going to talk about functions. We're going to be doing proofs with functions. But first we're going to start off with the very basics and define what a function is. And you probably remember from high school even that a function you can think of as a black box. And if you plug in a number into that function, exactly one number comes out of it. So if you plug in a 2 and 8 comes out, that means every time you plug in a 2, the number 8 is going to come out. Only one number can come out for each number that goes in. Now that's kind of the high school way of looking at it. Let's come up with some formal definitions now. A function, which could be called a map or a mapping, from A to B. A and B are both sets. Frequently for us, they're both going to be real numbers. So the function from A to B, it's a rule or a formula that assigns to each value of little a in the set big A a unique, that means one, number b, little b, from the set B. So in this case, we're starting from A. That's the numbers that the function is operating on. A is the domain. And B is simply called the codomain. So if we have this situation, that terminology, F colon, that colon could be a vertical line as well. It says that F is a function mapping A into B. And if we have some number or some object A, little a, from the capital A, we would say that B is equal to F of A. So that means that B is the number corresponding to the input value A. You could almost think of A as being the input and B as being the output of the function. And we usually draw a function kind of like this, saying it's operating on A. That's definitely the domain of the function. Every element in here, it's operated on by F, and the output will be a number or an element from the set B. Okay, so let's say we have one specific little point here where A, and it gets mapped to B. That's like saying F of A is equal to B, written in the reverse order. A, apply F, takes you to B. B is the image of A. You could say it's the image of A under the function F, but I'll frequently leave that off. And if you go the other direction, A is the pre-image of B. Well, you can also define the image for the entire function. That's what you get. It's all of the elements in B that get mapped to by an element from A under that function. So the image of F, which actually could be called the range of F, either one of those is acceptable. The image of F is the set of all of the B values in the set B that get mapped to. So I'm going to say it's a set of all B's such that, the colon is such that, there exists an A in A such that F of A equals little b. I use some terminology I think we're all familiar with. Okay, so it's all of the B's over here that have an A that gets mapped to them. Because it's not necessary for a function to map A into B that every single B has something mapping to it. There could be some left alone that don't get mapped to. We'll discuss that more later. The image of the set X. Now X is going to be a subset of A. Think of it as a proper subset. Subset that's smaller than A, completely contained inside A. Well, the image of that is going to be the set of all B's in B such that there exists a little x in X such that f of little x is equal to B. Let's see, did I say that right? Nope, I didn't say that right. No, there's a, yeah, that is right. It's a set of all the B's such that there's an x that gets mapped to that B. And the last one, the graph of F is just a set of all of the ordered pairs on the graph. When we actually draw the graph, that's a pictorial representation of all of the ordered pairs. So the graph is actually all of the ordered pairs Remember what this means? All of the ordered pairs that are in the Cartesian product of A and B. So you pick little a from A, little b from B, that's an ordered pair, where B, all I have to say is B equals f of A. That's the set of all the ordered pairs, that's the graph of F. Sometimes I will even say it's the graph of A. It's the image of A, it's the graph of the function. The image of, you can say the image of F is the same as the image of A under F. So that's the graph, the set of all ordered pairs.